Understanding TCP IP. Oh boy, more TCP IP. This is Joe Wilson again with Router Freak, and now we're into Module 5, and we're going to be talking about our friends TCP IP. We're going to be looking at TCP IP and UDP communications and how what the differences are between TCP and UDP. We're going to look at the TCP three-way handshake, make sure we get a good understanding of that. We're going to look at TCP sequence numbers and acknowledgments. And we're also going to go over TCP windowing. And what is TCP windowing? In our last module, we went over a bit about how TCP IP works across our network. And we're going to get into some more about how it works as we move along. So, to review, the format for the IP address has what three things? We have to have four numbers, octets, and they range from 0 through 255 in each of the fields, right here. They have to have an IP address. Obviously, that comprises the IP address, sorry. It has to have a mask, and it has to have a gateway. That subnet mask identifies which portion of the address is the network and which portion is the host. So if we go back, let me get my little handy dandy marker out again. Let's change my color. I just like to be black. So with 255.255.255.0, again, our network portion is right here. La la la. There we go. So this is our network portion and this is our host portion. And look, I've got my same duplicate IP address on my network. Boy, where's my quality control around here, I tell you. So when our packets flow across our network, we're going to go from our host to our router and then out to the rest of the world. And all this is pretty much a review from what we did in the last module, just so you can kind of get familiar with where we are. But we're moving up in the OSI model. We're going to be going up to layer 4. Now, as Donkey said, what are we doing? It's layers. That's right. We're peeling back the onion, getting into more layers. And we're going to move up from the network layer that we were at before, and we're going to go up into the transport layer. And that's where TCP and UDP live. And it's these layers that, well, this is where the communication happens. This is where we communicate. So we're going to look at the differences between TCP and UDP and why we use them. So real quick, TCP is for, basically, it's reliable communications. It's for our reliable stuff that we want. UDP is unreliable communications. Well, you might be saying, well, why would I want anything to be unreliable? Well, there are a lot of good reasons, and I'll get into that in a bit. Real quick, TCP IP is connection oriented, uses sequence numbers, and is, like I said, is reliable. And what that means, it uses acknowledgments, and we'll start talking about what a three-way handshake is and how that relates to what we're doing. UDP is connectionless, is best effort delivery, and is unreliable. So let's look at this UDP and see if we can answer some of these questions. So it's connectionless. So what UDP basically is it's kind of like the post office, where I'm going to send a letter in the mail, and the postman doesn't acknowledge that he picks it up, and I never get an acknowledgement that say if I send a letter to my mom, I never get an acknowledgement that my mom received the letter. So UDP is similar to the mail in that it's a connectionless. I don't have a handoff with the mailman. I mean, yeah, you could, if you're talking about the postal service, you could, you could go certified mail and all this stuff. I'm just talking about just regular standard old mail. It's best effort, right? It could get lost along the way. That's why you never really want to send money in the mail, right? Because that envelope could get lost, and then, you know, well, if there's money in it, well, it'll get lost too. And it's unreliable. Now, unreliable, that's not... we got to kind of take that with a grain of salt, because even though we say it's unreliable, I guess maybe we should say there's no guarantee, right, that it'll get there. Most of the time it gets there, kind of like the post office, right? Most of the time, 99% of the time, it gets there, right? But there is no guarantee that you will make it from, you know, from the source to the destination. So why would we want something, a UDP type of communication? Well, a lot of times we need UDP for things that are fast, very, very fast. We can't stop to say, here's my envelope. Did you get my envelope? Yeah, I got my envelope. I got your envelope. Okay, thank you for taking my envelope. Sure, no problem. And then each step along the way, it's guaranteeing, basically having somebody sign, I've received this package, take it to the next step, the next person signs it, and then so on and so forth, all the way down the line. And then each time I get notified that that process happens. So we have voice and video are two big things that when they're streaming across the network, it's best effort, right? We're gonna take some precautions to make sure that it does get there, but for the most part, the communication is sent UDP. It is sent as fast as you can send it, and as immediate as you can. But we don't want to waste the overhead with guarantees that, yeah, these packets will get there. Now, conversely, with TCP, it is connection oriented. It does have some guarantees and some ability to retransmit and sequence these things, so that when your message gets to the other end, it can be reassembled and put back together again, and we know that the entire message was there. It arrived the way we intended. So how do these two work? What are the differences? So with UDP basically, we're just going to send a packet that way and hope it gets there. There's no... the other server at the other end never lets us know, doesn't ever send us anything to let us know whether they received it or not. We just keep sending over and over again. Keep sending packets over and over again. And we never are told whether it gets there. Something could happen along the way, and some of these packets might fail, and we would never know. Now, for the most part, you'll lose maybe one every once in a while, but for the most part, they will get through. Now, with TCP, because it's connection oriented, it involves this thing known as a three-way handshake. Now, and what happens is, when a computer comes on the line, it's going to establish a TCP connection with the other end. And what's going to happen is this computer is going to come up, and the first thing it's going to do is it's going to send a SYN packet, or a synchronized packet, to the other side. And this synchronized packet, what that synchronized packet basically does is it telling the other computer, hey, are you there? Are you ready to accept my traffic? And this computer comes back and he sends a SYN acknowledgement, or a SYN-ACK, a synchronized acknowledgement. Then my computer will then turn around and send a final ACK, or a final acknowledgement, to say, okay, I acknowledge your acknowledgement. Let's get going. Let's get sending the traffic back and forth. So that's what a three-way handshake is. We send a SYN, then a SYN-ACK, and then a final acknowledgement, a final ACK. So SYN, SYN-ACK, ACK. That is the TCP three-way handshake. Once that's established, a TCP session is established, and packets begin to get sent back and forth. So when we're sending these packets back and forth, one of the things that occurs is a sequence number is put onto a packet, is labeled onto a packet. And a sequence number is really just the sequence that the packets were sent, the order of the packets as they're sent across the network. So one thing that happens when packets are being sent, once the three-way handshake is established, computer A, let's put some labels on here. Computer A, and we'll put computer B. Even though this guy's over here, he's a server, we're going to say that. So computer A is going to send a packet with a sequence number of 19, and it gets sent across. And computer B is going to send an acknowledgement of, it's going to ACK 20. So it's going to send sequence 19. He's going to send an ACK. He's going to acknowledge 20. When that acknowledgement goes back, it lets the computer A say, okay, this acknowledgement is the next packet that this computer is expecting, computer B is expecting to receive. He's also going to send his own sequence number. So computer A sends a sequence number 19. Computer B is going to send his own sequence number along with an acknowledgement of the next packet he's expecting to see. So in this case, when packet sequence 19 was sent, computer B is going to send sequence 5, packet with a sequence number 5, and acknowledgement of 20. Computer A sees that and says, okay, I'm going to send my next packet, which is sequence 20, packet sequence 20, and I'm going to acknowledge with the next package that I'm expecting, which is number 6. Server B gets it and says, okay, I'm going to acknowledge number 21, which is the next packet I'm expecting, and I'm going to send sequence packet number 6 because you told me you're going to acknowledge 6. You're acknowledging 6. That's the one that you're expecting to see, and that's the one I'm going to send you. So with all this sequencing and acknowledgement, we're going to dig deeper and kind of throw in a little bit more, another concept, which is called TCP windowing. So when we have this sequencing and acknowledging going back and forth, what's happening is we're going to send a payload of information. And consider it like a little bucket, if you want to say this is like a little bucket. And we're going to send one bucket across. And computer B is going to acknowledge that they received that one bucket. Well, if that one packet goes across and they receive it, then the next thing that computer A is going to do, oh, let's put our labels back up here. We don't have our labels. Computer A and computer B. So the next thing computer A is going to say, well, it's like, well, God, one bucket went across. How about, let's try sending 2 buckets. So he sends 2 buckets across. And computer B will acknowledge, hey, I got your 2 buckets. Oh, awesome. So now computer A says, well, man, let's try 3 buckets. So he sends 3 buckets across, and computer B acknowledges that they got the 3 buckets. So that's the idea, the concept between TCP windowing, is that the TCP payload size is going to keep getting bigger and bigger as communication goes along. So if this is a nice reliable circuit between these two routers, between computer A and computer B, then computer A is going to start making that window bigger. That TCP payload size is going to get bigger and bigger as the server B is going to acknowledge, hey, I'm getting it, I keep receiving it, everything is fine. So now let's look at this with sequence numbers and acknowledgments. And this is kind of where it might get a little confusing. So here we have our bucket, right? And we have computer A over here. And we have computer B. So computer A is going to send a packet that has sequence number 1. And computer A is going to get that, and he's going to acknowledge. He's going to acknowledge with what? He's going to acknowledge with a number 2, because why? Because that's the packet number, sequence number, that he's next expecting, right? So he received 1, he's going to acknowledge 2. So then computer A opens up his TCP window just a little bit more. He's going to send packets sequence 2 and sequence 3 now. So he's sending 2 buckets full. He's going to send it over here to server B. He gets it fine. He's going to acknowledge back with sequence 4, right? Sends it back over there. Boom. All right, I'm acknowledging 4. That means he's telling computer A, I've received sequence 2 and 3. You can send me 4. So now what A is going to do is he's going to open it up even more. He's going to send 4, 5, and 6. Send him 4, 5, and 6. Wham! 4, 5, and 6. All right. Hey, I got that. Looks good. I'm acknowledging 6. Wait a minute. I'm acknowledging 6. I sent you 6. I sent you 4, 5, and 6. So what's that saying? What does that mean? Well, if I sent you 4, 5, and 6, and you're expecting the next packet to be 6, what does that say? Well, it's telling me that he didn't get 6. He didn't get packet 6 that I sent him. Oh man. So what that means is it tells computer A, hey, 3 buckets might be too big. I may need to reduce the size. I may need to go back down to 2 buckets. So what I'm going to do is I'm going to resend packet 6, and I'm going to send packet 7. And then what computer B would then do is he would then ACK 8. And it kind of goes back and forth along the way as this communication goes back and forth. And the window goes up and the window goes down. That's why they call it a sliding window, a TCP sliding window, is because what TCP does is it slowly slides that window open, that TCP payload window open, so we can send more traffic back and forth until it can't send any more. And then what it'll do is it then reduces the size of the window and makes that smaller, makes the payload smaller, until it can finally agree, on what the best size is. Now, and so if you think about that, the reason TCP does that is so we can get the best performance out of our circuits. So if I had like some amazing thing, we have like a 10 gigabit circuit right here, and it's super reliable, it's like a direct connection, the TCP window can really max itself out because we have a highly reliable, high-speed circuit that we can send traffic on. So we want to send as much as we can, as fast as we can. So that's a lot to take in, I guess. What did you think about that? Now that's basically it. Let me go back to that last slide. So that's the gist of what we really want to get across here in this lesson today, is fully understanding how sequence numbers work, how they work with TCP, and how sliding windows, TCP sliding windows work. Today we went over the differences between TCP and UDP, and what were they? TCP is considered connection oriented, it's reliable, right? And it also has it uses what's called a three-way handshake. UDP, on the other hand, is connection-less, and it's considered unreliable. The TCP three-way handshake we discussed, and what is that? That's where we have a SYN ACK, right? And then finally, the third part of the three-way handshake is a what? It's an ACK. We reviewed TCP sequence numbers and acknowledgments of those TCP sequence numbers. We showed how when a TCP packet is sent, it'll be sent with a sequence of 2, and the remote end will send his own sequence packet, right? And will also send an acknowledgement, and in that acknowledgement we'll have a number of what the next sequence that computer is expecting to see. So then over here, the computer A would then ACK with 6 because he got 5, he's going to ACK 6, and then he's going to send another sequence of 3, and it goes back and forth. Then we looked at TCP windowing, and we looked at how these sequence and acknowledgments relate to TCP windowing, and how the TCP window size is going to keep getting bigger until we start losing traffic, until we start dropping packets, and then the window will automatically close back up or reduce its size, and eventually it'll go back and forth to this expanding and contracting until an optimal size is found, and then it'll stay there. It'll stay there primarily for the duration of that session or that data transfer. So that's about it for TCP/IP. I hope you found this lesson enjoyable, and I look forward to talking with you again as we get into Module 6 and our next lesson.